Hello everyone. In this video, it is part two of our properties of soil. So if you didn't catch part one or you need a quick review, of course, if you didn't catch part one, go make sure you go watch it. If you need a little refresher from part one, we talked about four of the properties of soil. There are some more properties of soil, but we just talked about four of them in part one, which is color or the shade or the hue that you see. So that's something maybe like a brown or a gold or whatever color that you see of that particular soil sample, the texture, how it feels, or the consistency of the surface as you kind of rub it through your hand. So is it bumpy? Is it smooth? Is it hard or soft? Then we talked about particle size, and particle size is the size of the individual grain or sediment. So when we talked about, like, for example, the sand as one of the great things that I always talk about. So if we go to the beach, right, and we look at all the sand along the beach, if we just pick up a handful of sand, those individual sand pieces are really small. And those are kind of what we're talking about when we talk about particle size. It's one piece of soil or one little grain of sand, even though there's a lot of them at one time, we're talking about the individual size. And the last property we talked about of soil was the ability to roll into the ball, or can the soil can it roll into a nice little ball easily after being exposed to some water? So can it roll into a ball or can it not roll into a ball? And as we talked about, topsoil, which is some of the most soil that we see, can easily roll into a ball, whereas something like humus doesn't always have the ability to roll into the ball. So what are we going to talk about today in part two? We're going to talk about water retention. What is water retention? Water retention is when or soil holds water or keeps water in it. So let's talk about water retention. So this is an excellent picture. So as we see here, we have water being poured in. That's our first step when we talk about water retention. We have to about water being poured in. So we have to have water being poured in, and of course we have to have our soil. So here is our soil right here. So water retention is the ability for the soil to keep the water. Now, why is this important? Well, when we talk about the ability to maintain water, if the soil can hold in a lot of water, it's able to give nutrients to the plant. So the plant, to survive or to be able to thrive, it needs a lot of things. It needs access to light for photosynthesis, and it also needs nutrient-rich soil. And part of nutrient-rich soil is to be able to have access to water. And so if our soil is able to hold or keep that water, then it's able to better support the plants in that environment. So again, water retention is when is how much or when water or soil holds the water or keeps it in. Now we see here, if I look here, we have, let's not use green. Let's use white. Here we have a big puddle of water. So if you've ever poured water into a plant pot before or anything like that, and it kind of just goes to the top, that's water. That's not all. So we have water that's being drained and water that's being retained. And we're going to talk about those kind of things today. Sometimes that water is being able to be retained in the soil, and sometimes water or soil can only hold in so much water. And once it holds so much water, after a while, it can't hold that water in, and that water becomes drained. So how do we test soil for water retention? So here is a good example that a lot of people set up a science experiment for. So the first thing we have to do is we have to have our soil. So usually we put our soil here into Ooh, it's hard to see. Let's go back and try again. We put our soil here. That's better. And what we're going to do to test how water keeps soil in is we're going to start to pour that water. So we're going to pour water onto the soil. So we're going to pour water onto the soil. And so here are drops of water going onto the soil. And so if the soil is able to retain the water stays here. So if the soil is able to keep the water, then the water is retained. That's the water that's able to the soil can hold. And again, soil can only hold so much water. After a while, the soil can't hold that water in. So what happens is as the water, after the soil can't hold in any water, it begins to drip down and out of the soil. And we can measure how much is retained by looking at how much the water it can't hold. So after a while, let's say there's some nice water in the bottom that it can't hold. This water right here is called the water that's drained. So if we pour water in to the soil sample, the water that stays in the soil, the water that the soil is able to hold is the retained water. After a while, soil can only hold in so much water, and then that water begins to not become useful to the soil. And we call that water drained water because that's the water that it can't hold. And so we're able to kind of test for water retention, or that retention means how much it's able to keep, by figuring out how much water is drained at the bottom. So let's look at an example. So let's try a soil retention problem in action. Mr. Rainey wants to test the effectiveness of a certain soil's ability to retain water. He poured 100 cubic centimeters of water onto the soil. Using the graduated cylinder to the right, how much water was the soil sample able to retain? So scientists use two types of things when they're kind of collecting a liquid. They can use a beaker, like was in the last picture, or we can use a graduated cylinder, which is what's over here to the right, which we're going to look at. So Mr. Rainey has 100 cubic centimeters. So let's underline that. He pours in 100 cubic centimeters. So let's come back to our picture. And so if we come here, Mr. Rainey is pouring in 100 cubic centimeters, cc's. So he pours in 100 cc's into our soil. And of course, our soil is what is in our little funnel. So imagine we put soil in that funnel. Now, it says, look at the graduated cylinder to the right. Well, if we look to the right, let's look. If we look right here in yellow, it goes up to 80. So right here, as the soil was retaining the water, 80 cubic centimeters of water fell to the bottom. It fell into the graduated cylinder or into the beaker. And so Mr. Rainey poured in 100 cubic centimeters. So 100 cubic centimeters, 100 cc's. When he looked in the graduated cylinder, it drained it drained 80 cubic centimeters. It drained 80 cubic centimeters, 80 cc's. So if he poured in 100 and drained 80, so 80 wasn't being able to be retained, if we do 100, which is the total water, and we subtract 80, which is how much was drained, which was how much was at the bottom of that graduated cylinder, let's look at what happens. 0 minus 0 is 0. 0 minus 8, well, we can't do that, so we have to borrow from the hundreds place. So we have 0 hundreds and 10 tens. 10 minus 8 is 2. There's an imaginary 0 here. So 0 minus 0 is 0. So we have 20. Now this 20 represents our retained. And it represents our retained because we saw 80 centimeters was drained. 80 centimeters was at the bottom, was in our graduated cylinder, was in our beaker. And so if we saw that 80 of the 80 cubic centimeters of that water wasn't able to be held by the soil, so 80 cubic centimeters of that water, of that 100, could not be held by the water, that means only 20 of the cubic centimeters of the 100 could be retained by the soil. And so 20 centimeters is retained. So in summary, we have a property of soil called water retention. Water retention is the ability of the soil to be able to hold or keep water in once it's been poured or exposed to that water. We test for water retention by pouring a certain amount of water into a soil sample. And during these labs and during a lot of things when scientists are testing it, we kind of have a funnel and a beaker at the bottom. That beaker at the bottom represents how much water is drained, and the water that's retained is the water that the soil can hold in. We're able to find the retained water by looking at the drained water and subtracting it from the total, because we can't measure exactly just by looking at it how much water is retained. So we first have to figure out how much is drained, and then if we subtract the total from the drained, we end up getting how much water is retained. So that will conclude part 2, and I can't wait to see you guys in part 3.